Today I continue with the problems on set theory, and of course this is the last part of this topic. Here you want to understand the nature of the problems that already I have told you. Today I want to see some problems on part B which carries 2 marks, and later on I will see the problems on part C. There it carries 3 marks. Let us understand this. So far in part B I have completed 15 problems. Today I am going to see that 16th one, how to find the required result. Look this problem. In a class of 35 students, 24 like to play cricket, 5 likes to play both cricket and football. Find how many students like to play football. So here it is not necessary that to write compulsory that cricket and football. C stands for cricket, F stands for football, that we can write it. But here you have to collect the information first, then you think which formula is required to use. In a class of 35 students, that is the nothing but here you have to see that that out of 35 at least one is to play either the cricket or football. So that is given n of that cricket as well as football. See this. Out of 35 students, that at least one should see that they are playing either the cricket or the football. So in a class of 35 means all 35 students are either in cricket team or in football team. The total students, union, n of C union, that is nothing but 35. Try to understand how to write. Later on you see, out of 35, 24 likes to play cricket. This number of students like to play cricket is how much? 24. And 5 likes to play both cricket. See, 5, both means intersection. That is called, here it is 5. And what is the question? Find how many students like to play football. That means n of f is required. Once again you have to collect the information. Of course it is simple because it is under part B which carries 2 marks, so that you have to write the minimum number of steps. And now I have to use one formula that we have already seen. The formula here you see, I write we have the formula n of C union f is equal to formula n of C n of f minus n of C intersection f. This is the formula. You have to substitute, and this gives, this is 35, n of C is 24, and n of f is required, n of C intersection f is, that is 5. So now this implies, try to understand, n of f is equal to 35 minus 24 plus 5. You have to keep it here, we have to send all these 6. And here you have to see that how many play football, that we can understand. 35 plus 5 means here you see that 40 minus 24. So here you are understanding that here you have to see that how many students that are playing football. So what you do it, you have to subtract 20. See this, and here you have to see that 16. So the number of students playing football is 16. This is a way why I am writing in brief, because these questions sometimes we see in part B which carries only 2 marks, and you have to write only to that extent. I hope you understood this formula. This we have already proved it. Now I want to see the next problem, that how to find the required result as per the statement. And here I want to see that number 17, you see that. What is this? Taking, very interesting, this taking set of natural numbers. Set of natural numbers as the universal set. As the universal set. And here you see that if A is equal to x such that x belongs to n and 2x plus 1 is greater than 10, and another one is B, look this, x such that x belongs to n and 3x minus 1 is greater than 8. So look here, what is the question here? You have to see that what is the question here, you have to find out. That question is that if it is the case, question is what here? Find A dash and B dash. This is the question. Now I have to write the solution. That is complement of A and complement of B. For that we need first, we have, see, what is the universal set? U is a set of natural numbers. 1, 2, 3, 4. And set of natural numbers are this. This is given U, universal set. And A is, look this, A is those numbers of natural numbers which satisfy this inequality, and it should be greater than 10. Suppose if you say that 1, it becomes 3, 2, it becomes 5, and you have to see that suppose if you say 3, 7 it happens, 4, 9 it happens, 5 into 10, 11, and you have to see that the number is next greater than 10 means it should be 5. Why? 5 2s are 10. 10 plus 11, 11 is greater than. Suppose if you take 4, 8, 9, and it should not be greater means first number is 5. I hope you understood why I have taken 5. If you take 4, it is not greater than 10. So that you have to, next number you have to write 6, 7, and definitely no end here. This is the numbers in the set A, you can see. And similarly, you see that B. Try to understand. This should be greater than 8. Suppose 1, no, 2, 7, no, and 4, 3s are 12. 12 minus 1. Even you see that the number 3, 3, 9. 9 minus 1 is 8. And 3 is not possible. 3, 3, 9, 9 minus 1 is 8 is greater than 8. No. It should be 4. 4 3s are 12. 12 minus 1, 11. 11 is greater than. So that you have to see that first number is 4, you have to see this. And next you can see that 5, 6, 7, you can continue. I hope you understood that how we write all these numbers A and B. Now the question is complement of A. You have to write excluding these numbers and in the universal set. Universal set means here. So here universal set is like this. So excluding these, and what are the elements remain here? That is 1, 2, 3. Excluding 5 has to avoid. So 1, 2, 3, 4. 1, 2, 3, 4. A complement is 1, 2, 3, 4. I hope you understood it. All the elements which are not in A, that we have to take it under the complementation. And that it should be written. So likewise B dash, same complement you have to see. And only excluding these numbers. Excluding these numbers means you have to see that. And in the universal set 1, 2, 3. So 1, 2, 3. So these are the elements you can see in the A complement and B complement. I hope you understood that how you write the complementation, because these A and B are in the set builder form, and that we have written in the register form. Then we have written A complement and B complement. So next problem, you see that also something different, because here all the numbers which we take slightly different comparatively, which we are taking one by one. So the next one is see, using properties, I say, using properties of sets show that A union interpret A intersection B is equal to A. We have to prove it by using the properties of sets, either the intersection or the union. So that A union intersection, of course this can be proved with example, but that is not the question here, because you have to use the property, then you have to prove it. A intersection B, and here you have to use this intersection union, means distributive law you have to use it. What is the distributive law? A union A, see, A union A and intersection A union B. I hope this property that we have already seen, that is called this is a distributive law, you can see. What you say? Distributive law. According to distributive law, that union it distributes over the intersection. And here you see that A union A is A. Look this. And also you have to understand that property says A union A is always A only. There is no question now. And ultimately you have to see that this is nothing but again, if you say that intersection A union B, so this is A. Why you may tell that A is a subset of A union B. A is a subset of, so that is the result. What is the result? A union interpret A intersection B equal to A. So you can see that hence the result. And try to understand that how the property is used. It is for 2 marks, they may ask to proving, not with the examples, with the properties. Only one property is used mainly, that is called distributive law, taking union and intersection. Now you see that next problem. Here, see that problem is simple. I don't want to take the next, only which are not easy to do it, that I am taking here. So number 20 I am taking here in the, because already you have got these notes, so you refer it, and only the difficult sums I am taking here. If U equal to, universal set is equal to X such that X is less than or equal to 10, and those are must be natural numbers. This is called universal set. X is less than or equal to 10, and that X must be the natural number. And what is A is given? See, A is given X is such that X must be natural number, and you see that X is prime, you have to take. X is prime, means prime number. And B is what is given? X such that, and you have to see that only that such that X is even number. Simply that X is even. The question is, write A intersection B complement in a roster form. What you see? In a roster form. And this is a question, you see how this can be done. And most of the things can be understood indirectly. Universal set, you have taken that. This is in the which form? Set builder form. Better you write in the roster form, set builder. And which are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, and even 10 less than or equal. These are the numbers. Because you see that these are the natural numbers. And you tell me what is X? What is this A? X belongs to X is a prime number. Which are the prime numbers? You know that 2, see, prime number is 2, 3, 5, 7, and look, 1 is not a prime. Look that. Here you see that 2, 3, 5, 7, and these are the prime number. Prime numbers are those which are divisible by themselves and 1. And similarly, B is what here? Look this, B is, and don't think that here one more confusing, you may see that X is a prime means some other prime numbers are there, but those prime numbers you need not take. With respect to the universal sets you have to follow. Even 11 is also a prime number, 17 is also a prime number, 19 is also a prime number. Why you are not taking accordingly this? These two sets are considered under the universal set. That is why you are not supposed to take. And B is even. Even means you have to see that even natural numbers 2, 4, 6, 8, and here 10. Here see, and here you have to see that only those natural numbers you have to consider, and accordingly you can see the result here. So I hope that how we take it 2, 4, 6, 8, 10 according to the even numbers. Now question is what? Now therefore A intersection B dash is equal to A, you write what is A? 2, 3, 5, 7, and intersection, and what is B dash? So excluding these numbers in universal set 2, 4, and you have to drop it these 2, 4, and here one is missing 6, 7, 8. 1, 2, 3, 4, 5, 6, right? 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the set of natural numbers. Now you see that B dash, 2 is not there because there 4 is not, 6 is not, 8 is not, 10. So remaining what? 1, you see, 3, 5, 7, 9. Yes, these are the B complement. B complement means which are not in B. All the elements of the universal set we have to take. So this is the case. Now this intersection. What are the common? You see 2 is common? No. 3 is yes. 5 is common? Yes. 7 is common? Yes. No next number here. So the answer is 3, 5, 7. So this is the way how we find. Only the thing is you can understand while writing A and B, you think that these are the subsets of the universal set. Don't ask the question prime, so many primes are there, so many even numbers are there. These never be greater than the universal set. Universal set is a set, it is a superset of all the sets given under consideration. That is why we have to take like this. Next problem, you see that, how that can be done. Number, see if it is easy then I am leaving for you, and accordingly we can continue. So the question is 21, don't get confusion this, that given what is A, 2, 3, and what is B, X, such that X is solution of x square plus 5x plus 6 is equal to 0. And try to understand that the question is what? Find A union B. See that simple, and I write A union B is equal to, what is A? 2, 3. What is union? What is B? B is X is the solution. What is the solution of this quadratic equation? -2 and -3. You solve it, and what is the union? You can see this union is 2, 3, -2, minus. This is the case. Try to understand when you are solving according to the factorization method, we will get the solution x is equal to -2 and -3. Accordingly, you can write. So next is easy, and I hope that these are the problems sufficient for you to solve here. The rest which I have left it 2, 3 problems that can be done at home. If not, either you send it through the WhatsApp or you can call Antoine after 8 o'clock in the evening. So now let us see that some problems I want to consider under part C. That's also equally important for us. So here in part C means the question, each question that carries how many marks? 3 marks. So now I am taking part C questions 3 marks first, 3 marks, because very important, because no other than this 3 marks is. First question I am going to write it, and here first problem I want to take, otherwise it is getting confusion. Look this, if x and y are 2 sets, x and y are 2 sets such that, see what is given, try to understand, such that x union y has 50 elements. How many elements x union y? 50 elements. And x has 28 elements. X has 28 elements. And y has how many? 32 elements. See this condition. Question is how many elements? Question is how many elements you can see does x intersection y. This is the question, and accordingly you have to understand. Very simple. That one question we have seen in part B, the same way you have to write the given information very quickly. X and y are 2 sets, given what? X union, no, number of elements in x union y is given how much? 50. And number of elements in x that has given, x has 28. Number of elements y has, that is given 32. Question asked, how many elements does number of elements in x in union y? This is the question. One formula we have, this is a common formula, important formula that you know, n of x union y is equal to n of x, n of y minus n of x intersection y, this formula. So here n of x and y is 50, n of x is 28, this is y is 32, minus question is, this is question asked. So what I say that you bring this n of x intersection y is equal to 28 plus 32 minus 50. So 28 plus 32. So here 60 minus 50. What is the answer? Then here you are getting here. The answer is you are getting 10 marks, 10 elements in the x intersection y. So this is the way how to work out these problems. Now similarly, I want to see some problems which are important and which you feel generally complicated in part C questions. This is one example I told you, the formula, how we are using, how we are simplifying this. And now you will see that very big statement and thereby how to write the answers I am telling you. And here some technique is there to solve the problems here. So suppose if you see that second one, look this. If in a school there are, I don't want to write the problem because the problems with you, and I read out and write the information. In a school there are 20 students who teach mathematics. So here you see that, look this, in a school there are 20 teachers who teach mathematics or physics. So look here, always you remember that in the statement, the two words we are using, are and, the word are, the word and. Look it once again, follow it to this point very carefully while writing the information. In the statement, if you say are word or and word, if are word is there, you have to go for union, because already I have told you the A union B is equal to X such that X belongs to A or X belongs to R. R means union. The definition, you know, what definition we have written that? What do you say? This A union B. A union B is X such that X belongs to A or X belongs to B. This is the definition. So union means the, what you say here, the R. R means union. Like that, A intersection B means X such that X belongs to A and X belongs to B. So what? And refers to intersection. So that is the point you have to follow. And just to read out. In a school there are 20 students who teach mathematics or physics. Mathematics or physics means you have to see that union or intersection. Or means what is a union. So that is why you have to write the answer here. Mathematics and physics, M union B, that is 20. Once again, in a school there are 20 teachers who teach mathematics or physics. That is why union I have written. Why I have written union? According to the definition. Next, of these 12 teach mathematics and 4 teach physics. So and is there, you know, what is to be done here, and here you have to go for using the word and accordingly the condition that what do you say, and M intersection P is equal to how many? Look this, 4 or 12 here. You have to see that 12 you see that once again 20 teachers who teach mathematics or physics. Of these 12 teach mathematics, and here you see 12 teach only mathematics, and there are 4 teach both physics and mathematics. And means here intersection. And the question is that how many teach physics? The question is N of P is equal to how much? So the formula that already you have seen. What formula? That A union B here, accordingly the sets. I hope you understood R and words, how we take it in writing the things. So now, formula that I am writing directly. N of M, mathematics, union, physics, formula is N of M plus N of P minus N of M intersection P. This is the formula. You have to substitute. N of M, you know, P is 20, so this implies 20, mathematics only 12, physics, that is question asked, and both 4. So the N of P is equal to 20 minus 12 plus 4. See, and 24 minus 12. And how many they teach physics you can understand here, and ultimately this is 24 minus 12 teach physics. This is the way how we understand according the formula. So now I want to explain that another problem, and accordingly, because I write only the information given in the statement, and even I write the formula how that can be simplified. See the next problem, and here you see that the problems are very simple, but the thing is that one should understand here. Next, number third one. In a class of 35 students, and 24 like to play cricket, 16 like to play football, and each element has to play at least one of the 2 games. That should be condition is given, must be given. How many students like to both cricket and football? The question here you have to understand what, see, how many students like to play both cricket and, so here try to understand cricket and again football. Cricket, football given, you see, and you may write that cricket is X, football is Y, or you can write the same that letters, that is how many. This is the question. Question is there, look the last part, how many students like to play both cricket and football? For that you have to see that what is given. See, in a class of 35 students, and definitely you are understanding that what is the value of this, and here you have to see that in a class 35, all 35 students must be under that universal set, but because here we have to see that union. Why union? Because at least, so that n of C union F is equal to total class strength. So here one thing is to be noted that in a class of 35 students, of course it is indirectly total strength, both together. But one more condition always given, each student likes to play of at least one of the two games, means union. And another is what is given, see that 24 like to play cricket. Cricket means n of C is given 24. And another is what n of Y is equal to football, how many? And here you have to see that particularly how many students, 24 like to play cricket and 16 like to football, that is called n of F is equal to 16. Look here, in a class of 35 students, that is union, and 24 like to play cricket, okay, C I have written, 16 like to play football, and that is n of F. And question is, how many students like to play both? Means this intersection is, and here you can substitute the formula, you can calculate what is the formula? Once again I say, it is common formula, n of C union F is equal to n of C plus n of F minus n of C intersection F. You substitute and finally you will get n of C intersection F. You see, simplified, already I have given the answer here, and only that 5 students like to play both cricket and football. See, all information out of 1, 2, 3, 4, and out of 4, 1, 2, 3, 4, it is not given. 3 must be given. So other which is not given is to be calculated. So this is the way how we find the answers for all these required things in the statement. Now let us see that next problem. And in all the problems which you have seen, only one formula is used. Sometimes other formula may be used here. And look here, this fourth problem, how this can be done. Look here, in a survey of 400 students in a school, that is means again you have to see, that is in a survey of here in the school strength, and there you see 100 were listed to taking apple juice, 150 taking orange juice, and 75 were listed as taking both apple as well as orange. How many students were taking neither apple juice nor orange juice? See, the question is very interesting here, and better if you understand with the Venn diagram, it is more clear, because Venn diagram is always better to understand the problem. I want to take it. See, this is some students like only apple juice. Suppose if you take A, and some A is apple juice, and this is football, that is what you say, one more juice is also apple and orange juice. So that is B, this is orange and this is apple juice, I can say. And accordingly you can see that how we have to take. See, question you say that in a class of 35 students, total is 35 in the universal set, you have to understand. This is the universal set, and here in this rectangular box, total number is 35. And next you see, 100 were listed taking apple is 100. And one thing is there, how many students were taking? And here one thing is there, 75 were listed as taking both apple juice as well as orange. How many are taking now here? That is only for both you have to see. And accordingly you can understand 75 were listed to take. So here is the 75. 75, it is a common, both orange and apple, and 75 is the common. First you write the common. Now you see that what is the orange? Orange is first the apple, you see. How many apple? 100 were listed as taking apple juice. Out of 100, 75 is already is there in the apple. And how many you have to write here? You have to write 25. Look here, in this apple circle must be 75 plus 25 is 100. And here out of this 100, 75 is in common. And now you see that oranges how many they are given? 150. And 75 is there. So it is 150. Look this. Total orange is 75 plus 30, common is 70, and it is 100. And here you see that particularly when you write all these numbers, and accordingly you have to see that total strength. And now you to follow that question now. This is 75, 75 is how much? 150. 150 plus 175. And what is the strength you have to see, accordingly you can write it. Now that union is how much? The rest all outside these things. U is given. What is that? N of U is given. Total strength is given. N of U is 400 is given. Total strength of the class is 400 is given. And how many apples is that is given in the statement? N of apple. Apple means A, that is 100 is given. Look that 100 were listed as taking apples is, and 150 as taking oranges. Orange here I have written that B is 150. And the question is that common is how much they are taking now here, and N of orange, apple, orange, and both this is how much? 75 is there. Now the question is now N of so look here, neither orange and here nor neither apple nor orange. N of A dash intersection B dash. So this is the question now. Try to understand. Leave it that Venn diagram. I tell you that later on. Total class strength is 400, in which apple juice, those who like, and 100, and orange is 150, and common is 75. The question is that how many students neither taking orange nor apple? So that is A stand for. That is why I have written the complement. So with this, I tell you how to calculate this N of A dash intersection B dash, and accordingly we can calculate. So first you have to write the result, and accordingly you can go for it. So one thing it is true that according to the De Morgan's laws, you know this, A union B dash is equal to, this is A dash intersection B dash, this is a De Morgan law, and one more De Morgan law is there, A intersection B dash is equal to A dash union B dash. These together are called De Morgan laws we tell. But here I can apply the De Morgan's law here. See what I tell. Look, this we want N of A complement intersection B complement. So this is according to the De Morgan's law. How you write? N of, you see that, union. This is intersection A union B dash. See, N of A union, I hope you have understood that. A dash intersection B dash can be written as A union B dash. Why? That is according to the De Morgan's law. And once you understand basically that result, how you write one over formula, because A complement, that is you have to write this N of A. A complement is always written that what? U minus, that is N of U. See, this is number of A dash. If you want to write N of universal set minus N of A, so that N of A dash will find. Number of elements in A dash equal to number of elements in U minus number of, that is a definition. The elements which are in the complement set which are not in A. So according to that formula, so you write that this is written N of U minus N of A, means N of A union B. See, this is the formula I have written accordingly this formula. N of U minus N of, so this is equal to N of U. You see this, and here you try to understand. I want to take it this. If you write, this is the way, and I can write. So N of U, and here N of U minus. Try to understand. I want to write N of A union B is what? N of A plus N of B minus N of A intersection B. Yes, this is the case. And you have to simplify for this. Or if you open the bracket, what happens is N of U minus n of A minus n of B minus minus plus n of B, it happens. So we want to calculate this n of A dash. So this is equal to, what is n of 400 strength is there, what is n of A value is 100 is there, what is n of B 150 is there, and what is n of B. So here you have to write 1 of n of A. This is what I write, that formula, n of A, and one is you write it, and accordingly you have to write that this is not n of A intersection B. What is n of A intersection B? A 75. So now you have to simplify that 400 minus 100 minus 150 plus 75. You simplify, will get 225. So 225 is that n of A dash intersection B dash, means that here you have to see that the students neither taking apple juice nor taking orange juice. So you have to understand the formula, n of A dash intersection B dash equal to n of A union B dash according to the De Morgan's law, and this you written according to the definition of complement. So I want to write one more of this same kind, because some students facing only when, neither, nor, and here I have to see that one more of the same kind that I take, and it becomes perfect. And this is only the problem when you see that difficult to see the answers. And here you see that question is how many students are taking 225. That is 225 easily, and that we can take it on the outside, we'll see that. So anyhow, we want to find out the result here. Accordingly, the statement, you see one more the same statement I'm going to consider here. And you see that that problem, when you are going to write it, A dash, B dash, so the same problem I want to continue here. And now you see that 150, 25, this is already there, and here now you see that out of 400 students, and you have taken that. Now I say that out of 600 students. Now problem number 8, you see in that list, in a survey of 600 students in a school, 150 students were found to be taking tea, 225 taking coffee, 120 were taking both. Find how many students were taking neither tea nor coffee. The same problem. And here coffee and tea, C and T. And here you have to write that question, that how to write it. Both coffee and tea. See, the question is that here how many students they are taking, accordingly you can go for it. And what is the total strength here? N of U. What is the strength of school? 600. That is there, number of total students of student. Now here you have to see that what is how many students they take tea. Look this, in a survey of 600 students in a school, 150 students were to be liking tea, and N of T is how much here? N of T is 150. And how many students they like the coffee now here? N of C is 2, how many? 225. 225, those who like coffee. And 100 were liking both. Both means intersection. So N of C C intersection T intersection C, coffee, that is 100. See, 1, 2, 3, 4. Here you have to see that how to calculate the result, and accordingly you have to see. First you have to see that if you calculate the result here, and accordingly you can write it. The question is that how many students were taking neither tea nor coffee. That I want to tell you here. So first of all, you have to calculate. U is there, T is there, C is there. But when you are going to use that formula, union is required, you know, that both. How many students taking either tea or coffee, that is not there. So that should be calculated first. And accordingly you can see the result, unless if you don't find and you cannot write, or you can go for directly what problem is there. So accordingly the result we can see. neither copy. What you see this n of t dash intersection copy. Yes, already I told you n of what do you say? N of what I already told you? T union C dash. And this already I told you n of u minus n of T union C. Yes, correct or not? And here you have to tell that n of E is how much? You have to once again write 1 of U, and here n of T formula minus n of C formula plus n of T intersection C. And you see the result, n of C is 600, n of minus T 150, n of C is 225, and both means 100. So altogether you will find the result that when you are subtracting all these and answer, you will see that 325. You can calculate it later on. This is the way how we find the results, and that can be determined. So the other problems you will see that likewise, but now I want to see that one more problem finally, and that should be the last. If necessary, I will say some other problems later on. Now the last problem you see here, the question is again from the miscellaneous part that I am considering, and in the simple way that I want to follow here. See the question number 9 here, as I already have given, and accordingly we can write the results. In a survey, it was found that 21 people liked product A. See how many they liked product A. N of A is equal to 21 they like. And next one you see in a survey it was found that 21 people liked product A, 26 liked product B. So N of B is 26. And you see that 29 liked product, and here you see that product B, and see here once again in a survey of it was found that 21 people liked the product A, 26 liked product B, 29 liked product C also. 29 product C is 29, and 14 people liked product A, B. See 14 A, B. A, B means like this. Try to understand how you write it. And A, B is both. And you have to see that if 14 people liked A and B, 12 people liked, you see that C and A. C and A. C and A. How many? 12. And here you see that 14 people liked product B and C. N of B and C. That is 14. And here you see that B and C, 8 liked all. 8 liked all means what? All product. A intersection B intersection C, that is 8. See how we write all this. N of A intersection B, and here you have to write C intersection A and B intersection C, N of A intersection B intersection C. The question is that, see, next question is what? Find how many like product C only. How many like product C only, not the 29. Here 29 is that liked product C. That they may like some other one. But here we have to see that only the product C. Product C means they like 29. Only that C we have to calculate. And here out of 29, some people may like other products. But strictly we want to find out how that should be written. The question is that here, question is we want, look this, N of C only. N of C only, not other products, and accordingly you can write it. So once again I write product A 21, product B 26, product C 29, product A and B 14, C and A 12, B and C 14, all 8. So how we calculate? Only C, and you don't get confusion that the like means 29 answer. No, this is, these people may like some other product, but strictly only C that you have to calculate. And I think this can be done easily, and accordingly I can write with the Venn diagram. This can be done easy for Venn diagram instead of writing everything. I tell you the Venn diagram how it is to be done. If you go for Venn diagram, I hope this is written very easily, and you can write the result interestingly. So here how many products here? I think Venn diagram is to be taken very big, and if you even you are facing a lot of confusion how to find out this C only. First I tell you the Venn diagram. Better you follow Venn diagram to answer for such questions. Look, this I want to tell. Very big Venn diagram I want to take it here for clarity purpose. How many products are there here? 3 products. See, one product is A. This is product A. And another one is product B. This is product B. And another one is product C. Look this. This is the way how to write it. Now you have to see that according to the definition only you write, and that is good for us. First you write that common elements, then we write the separate. First all three, A intersection B intersection, all three means here it comes, this is all 3 it comes, here is 8. Try to understand, it belongs to A, it belongs to B, it belongs to C. The product A, product B and product C, and 8 should be written first. Next what you have to write accordingly, product common. First you see A and B common, A and B. A and B is here, you know. A and B is there, you know. And accordingly you can write A and B. And here you have to see that A and B and A and C, and accordingly B and C you have to see that. When you go over writing that, when that common elements and B and C, A and B is how many? A and B 14. 14 means here, that already 8 is there. How many you have to see? Out of 14 minus result, that should be written here. So look here, if you don't write common here and here, that is 14, A and B is 14 is there, and out of 14 8 should be subtracted, and you see that 14 minus 8 is 6, so here is 6, and try to understand that how it is 6. B and C is 14, already 8 is there, so that we had 6. Now A and B, now we have to see B and C, C and A, C and A. C and A is how much? 12, and already C and A is already 8. How many here? And ultimately this is 4. I hope you understood how that is 4. Next B and C. B and C 12, and B and C. B and C already 8 is there, and here B and C is 14, and 14 and 14 again minus 8. See, again you have to see that 6, and here we will get 6. So I hope that when you are understanding all this, the question is that how many students only they like C only, and that we are interested. So one thing you remember, I don't want to write other parts that given A21. A21 means you have to write that 4 plus 8. 4 plus 8 means 12, 12 plus 6 means 18, and 21 minus 18 is to be written here. Like that you can write here. But here I want to write that only thing is that suppose if you say that n of C is 29. 29 here you see this 6 plus 4 10. 10 plus 8 18, and the question is given here, and accordingly you have to see the result here. But only thing is that when you write that they like only C, means that you will have to say that in C which are the elements, and out of C is how much? 29. Look this is totally C is 29, and here, and you have to delete this and this total C. Look here I write I may number of C only I write. See, already you told 29, okay, because answer is 29. But here, purely means here these elements we want to write. Yes, correct or not? 29, here all together is 29. But only thing is that we don't want this, we don't want this, we don't want, because out of 21, 4 go for A, 8 in common, and here you see that 6 in B, product. Out of this 8, you see that common, and here A, but total is 29. How this is 29 plus these, it should be subtracted, only C will get. So what? 29, you have to subtract what? 4 plus 8 plus 6. I hope you are understanding. This is totally what you say 29. Out of 29, this is to be subtracted. So how much will get? And don't calculate A only, you have to calculate, only B we can calculate. That is not the question. Question is related to C. That is why I am taking 29. And you have to write that see that 8 plus 6, you have to add it, that is 14. 14 plus 4 is how much? 14 plus 4 is 18. So shall I write here 18? So now 29 minus 18, you have to get it how many? This is 11. So that here is 11, because this is the answer. And this is only those who like C only. Like that we can calculate A only, we can calculate B only. The question is to calculate C only we are written. So this is the right answer. So only information, and with the hand when diagram, and you can write. So here the question is that how to calculate, that I have told you with the help of the Venn diagram. So without Venn diagram, and it's very complicated way to write the results. So this is a way, and of course another method is a lengthy process, is that I don't want. Better you do this example. If this example comes, definitely we'll see this only. So you have to calculate in this manner. So I hope that this is the problem which we can see in short with the help of the Venn diagram. One more class I take for this set theory, and which problems I have left it now, and will continue in the next class. Thank you.